let's say you have a function f of x equals x plus 1, and another function g of x equals x minus 1. These functions have a special name. They're called inverses. They are inverse functions, meaning they are like the opposite of each other. They would undo each other. In order to prove that, what we have to do is show that f of g of x equals x. Show that g of f of x also equals x. So let's see how that would work here. If I do, let's say, g of f of x, I'm talking about my first machine is f. And what f does is it takes the input and adds 1 to it. So if you put an x in on the left, you get out x plus 1. Just as a number example, like if you put in 3, you get out 4. And then you're going to use that as the input for g. Now what g does is g does x minus 1. So if you plug in that 4, what comes out? 3. You get back to what you started with. So the functions, they undid each other. And if you do that with a formula just in general, then what you're going to get out is x plus 1 minus 1, which is x. So what happens is the input and the output are the same. That's a special case. It means f and g are inverses of each other. Now you could look at it from a just formula approach without machines, and we have this definition of f of x being x plus 1. So if you just take that and plug it in down here, you would get g of x plus 1 is what you're trying to find. The formula for g, though, is to take whatever is in the parentheses and just subtract 1 from it. So if it was saying like g of apple, then the answer would be apple minus 1. You got g of x plus 1. So what is that? X plus 1 minus 1. See, the point is that you've got to do something minus 1. But the thing that goes there is the whole formula for f. So x plus 1 goes there. What you get, of course, is just x. So f and g are inverses.